Okay, in this problem, we read the function f is continuous. Okay, it is continuous for the interval from -2 to 2, and it tells us that the value at f -2 is equal to the value at f of 2, and they're both equal to 0. So this condition here, hypothesis, is the hypothesis for the Rolle's theorem. The value of the function at the endpoints of the interval are both zeros. Now in Rolle's theorem, it says that the function must be continuous and differentiable, and that there exists a c. So if the function is continuous and differentiable, and the values at the endpoints are both equal to 0, then there exists a c where f prime of c equals 0. So there exists a c between those two endpoints where the derivative becomes 0, meaning there's a maximum or a minimum. Okay? There's a maximum or a minimum. So if you recall, we had something like this, for example. Let's say we have something like that. So at the endpoints, they're both 0. It's continuous. So there must exist a c. In this case, there are 3 points where the derivative is equal to 0, right? So we find 3 values of c or the derivative of 0. The derivative is equal to 0, this one. There's actually 2 maximums and 1 minimum. Now, in this particular problem, it says here, if there is no c, so meaning the Rolle's theorem does not apply. So if there is no c where between -2 and 2 for which f prime of c equals 0, meaning the Rolle's theorem does not apply. There's no c. We cannot find that c where the f prime of c is equal to 0. So that only means that either the function is not differentiable or not continuous, but it already tells us that it is continuous. Okay, so that leaves us with the last possibility, that the function must not be differentiable. Okay, it might be continuous, but it must it shouldn't be differentiable, or the derivative does not exist. That's the reason why there is no such c. There's the reason why the Rolle's theorem does not apply. So A tells us the derivative is positive. So there is a derivative. B tells us that the derivative is negative. Still, there's a derivative. C tells us the derivative exists. Okay, so it's differentiable. D tells us the derivative exists, but f prime is not continuous. It says it exists, but it's not continuous. So D is questionable there, because it's telling us that the derivative exists, but it's not continuous. It rather contradicts itself, because when we say it's differentiable, it must be continuous, right? Now, for some k, for E now, for some k between -2 and 2, f prime of k does not exist. So this must be the one that's true to for us to conclude that there is no such c. You cannot find such c value where the derivative becomes equal to 0. This is the only condition where, or the only instance, the only case when the Rolle's theorem will not apply, when the derivative does not exist, when it's not differentiable. Okay, when it's not differentiable, because like D, if we go back to D, the f prime still exists. It tells us that the f prime still exists. So basically, D is still okay there. But E is the only one, the only condition where we won't be able to find that C, because f prime of gate, f prime of gate or the derivative does not exist, meaning it's not differentiable. Okay, I hope that becomes clear. Okay, thank you, Bob.